I'm Charles, and I'm with Staton Industrial Machine Service. I just wanted to take a minute to show you a couple things I've been working on. This is a dual blade hot knife controller. This is the part that I designed. This is a piece of machine that my customer owns. These are horns that during their manufacturing process, a string like this will come down the horn and it'll get cut off right there. That's a hot knife. The part that my customer is currently using is sort of cobbled together, and there's no current limiting or anything. And it doesn't use actual blades, it uses some pieces of scrap wire. So this unit is capable of putting out up to 100 amps at 10 volts. Right now I have the current limit set at 30 amps because that's all the blades can handle. They'll burn out. So what I'm doing is I have a phase angle fire SCR controller going into the primary of a step-down transformer, and that allows me to control the current at the hot knives. So these will start heating up. And it just parts the wire or the polymer real quick. So there will be an endless succession of strings coming down this horn, about that far apart for all day, for a 12-hour shift. And they'll just come down and get cut like that. Thousands and thousands of strings all day. And the other hot knife controllers out there in the market are intermittent duty. The one controller that was available for continuous duty was about $2,000, and I was able to design this for less than $2,000, and it controls 2 hot knife blades, whereas the commercially available hot knife controller only does 1. So it saved my customer a bunch of money and gave them a nice, elegant solution. You see their blades are starting to glow red hot now. That's good, and it'll sit there and do that all day, just cutting strings. Right now I'm using wires to simulate the hot knives. So what I got going on here is a transformer. This is a 120 volt to 5 volt transformer with the 200 amp output. I have a solid state relay and a phase angle firing controller. This is controlling the power input into the transformer, the 120 volts. And then coming out, we're going to these hot wires. And I've hooked up my oscilloscope so we can monitor the output. Okay, so I've turned it on just a little bit. And it's giving us 62 amps. Our wires are getting pretty hot there. Turn it up a little bit more. Okay, so we've hit our current limit, which is set by this little pot here. So it's not going to... Okay, it increased a little bit because the resistance of the wires goes up as they heat up. So now you see we're getting pretty hot there. And I can just give you a little demonstration here with this foam. Just cuts it. This is another thing that I designed. It's pretty simple. It's nothing special. Just a portable mold heater controller for a 2 kilowatt heater. Right now I'm demonstrating with this can of water. It's just a dummy load. It's coming up to temperature right now. We're up at 144. You just plug a thermocouple into it, plug the heater into it, and turn it on. And the PID controller will get you up to temperature and keep you there. And so they can use this wherever they want in the plant. They don't have to push around a cart or anything. Just carry it around. That's it.